The first of our grade 11 trigonometric videos taking us into the quadrants, in other words beyond the right angled triangle. There we are. We start at 0 degrees. Direction. Well, it's counterclockwise is positive and clockwise is negative. So any positive angle goes that way, negative goes this way. The order of the quadrants. Well, because we started north and go that way, here's quadrant 1. So it's 1, 2, 3, 4. The angles. Well, 0 degrees, then there's 90, 180, 270, 360. And it can go the other way, negative 90, negative 180, negative 270, negative 360. So 0, 90, 180, 270, 360, and of course we have all the negative ones. There we are. So they're the options, and it can go beyond that. The signs of the trigonometric functions. Now this depends on the x, y, and r values. R is always positive, but x is positive to the left, to the right, and negative to the left. Y is positive upwards and negative downwards, and R is always positive. So now let's relate it in the quadrants to this. If I have a look here, whichever pair we take there, we're going to get a positive. Therefore, all ratios are positive. Here, in order to get a positive, I have to take the y and the r. So therefore, y over r, sign is positive, the other ratios are negative. In this quadrant, to get a positive, I've got to take the y and the x, because negative over a negative will give us a positive. So tan will be positive, and all the rest negative. And here we need the x and the r to get a positive, which is cos, and the rest will be negative. There we are. Remembering it, there's the cast diagram, C-A-S-T. Note cast starting in the fourth quadrant. That's the way many remember it. The more skeptical teachers can remember it as all students try cribbing, and there are many other ways to remember it. All positive, S, S for sine, T, T for tan, C, C for cos. Here's just a little exercise to try yourself with finding the signs of these in the different quadrants. So we would say second quadrant, positive. Fourth quadrant, positive. Fourth quadrant, negative. Right, how do we get to these quadrants? Well, we know that we go theta in the first quadrant. Now, in the second quadrant, the important thing is I have to have the same x, y, r. So if you consider it, if it's sitting about over there, there's your theta there. In the third quadrant, if I'm going to have the same x, y, r, it will be about over there, which means, in fact, there's your theta there. In the fourth quadrant, I'd have to have it there. So there would be your theta. So for quadrant 2, there's your theta, so therefore the angle from here will be 180 degrees less the theta, 180 minus theta. Third quadrant, there is our theta, same, so therefore it's 180 plus theta to get there from here. And fourth quadrant, there's your theta, your matching x, y, and r, and therefore it's not all the way, it's 360 but minus that bit, 360 minus theta. So theta, 180 minus theta, 180 plus theta, and 360 minus theta. There's a full summary of the quadrants. Numbers 1, 2, 3, 4. Theta, 180 minus theta, 180 plus theta, 360 minus theta. And here's a summary of which are positive and obviously the rest negative. All positive, sine positive, tan positive, cos positive. Reduction formulae. What that means is we're going to reduce these trigonometric ratios to acute angles. So when I look at this, I say, well, what quadrant is that in? That's a third quadrant angle. How do I get to the third quadrant? 180 plus. So I'm going to write this as 180 plus what? There we are. Now this has not changed. It's exactly the same angle at the moment. But now I want to write just 34, not 180 plus 34. 180 plus 34 and 34 are not the same angle. I'll say that again. 180 plus 34 and 34 degrees are not the same angle, but they have the same x, y, and r. Which means that I can write sine of 34, but I'd have to say in the third quadrant, sine is negative. Because this is going to be the y over r, and the y is negative and the r is positive in the third quadrant. Therefore, negative sine 34. If I have a look at this one, at this stage, let's just add 360 onto it. So we get that, which means we get that. Now we can work from there. Right? You say, which quadrant? Fourth quadrant. 360 minus something. There we are. That and that have exactly the same value. I've changed nothing. I've just written it in another form. But now I can say, fourth quadrant, I can write 45,7 instead of 360 minus 45,7. Remember, they are not the same angle, but they have the same x, y, r, and all I have to decide is cos of a fourth quadrant positive. There you are. Here are a whole lot to do here. I'll go through the first couple of examples. Tan of 334, quadrant 4. How do we get there? 360 minus. Tan of in the fourth quadrant, negative. And I can write 26, so it's negative tan 26. I'm not saying 26 is the same as 360 minus 26, but I am saying they're having the same x, y, r, except the ratio is negative. 248 degrees. Third quadrant, 180 plus 68. No change, it's still the same angle. I write the same angle. Now I can say that has the same x, y, r as 68 degrees, but cos is negative. There we are. Sine of 134, second quadrant. How do I get there? 180 minus. 180 minus 46 gives me 134. No change, still the same angle. Now I'm going to write 46 degrees instead of 180 minus 46. Same x, y, r. And I say sine of a second quadrant angle, positive. So therefore straight. Tan of 285. That is the fourth quadrant. Therefore 360 minus 75. Now I can write just as the 75, but because it's fourth, I'll have to write negative tan 75. Cos of 109.8. Second quadrant. How do I get there? 180 minus. Cos of the second quadrant angle, negative. Therefore, negative cos 70.2. I'm going to remind you again. 70,2 and 180 minus 70,2 are very different angles, but they have the same x, y, r. Except that for this one, the x is negative. So therefore, the x over r becomes a negative. Tan of negative 135,7. Add your 360 on to get that. Which quadrant? Third. How do we get there? 180 plus. Third quadrant, tan positive. So I can write just positive tan 44,3. Bit of a mixed scroll. Let's mix things up. This is a very popular sort of question. If it's given that sine of 20 equals alpha, given terms of alpha, sine of 160. Now what I'm going to do is, I'm going to just reduce each of these first, and then I'll see if I have a problem. Note the other thing too, from the grade 10 trigonometry, that if you're told sine of 20 is alpha, that's giving you the y over the r. Y is alpha, r is 1. Keep that in mind. Y over r. Y alpha, r 1. So you can actually find the x by Pythagoras theorem. Let's start there to reduce. 180 minus sine of 180 minus 20, which is sine of 20. And sine of 20 equals alpha. There we are. So many people write sine of alpha and get it wrong. Notice sine of 20 equals alpha, sine of 20, therefore alpha. Let's reduce the next one. 360 minus 20 degrees. Fourth quadrant, still the same angle. Now say fourth quadrant, negative sine of 20. Well, I know sine of 20 is alpha, therefore negative sine 20, negative alpha. Next one, I'm going to add on 360. I get 200. Third quadrant, 180 plus 20. Third quadrant sine negative goes to 20. Not because 20 and 180 plus 20 are the same angle. They have the same x, y, r. Negative sine 20, there's sine 20, therefore negative a. Now, this next one here, cos of 20, that's a bit of a problem. But hang on, I know that sine of 20 is alpha. You know sine, which means alpha over 1. So have a look. Sine of 20 alpha, it's alpha over 1, so therefore y alpha r 1. Therefore, by Pythagoras theorem, I can find x. There we are. Now, usually, I'd have to put a plus or minus, because if I've got x squared equals that, then x is plus or minus the square root. But this is the first quadrant angle where we know cos x is positive. Therefore, I'm just going to write that. Now, please note, I can't say that's 1 minus alpha. You cannot square root a difference and square root them separately. So there's our cos 20, x over r. There's the x for 20 there, and there's our answer. Tan of 20, same sort of thing, y over x. Well, I know y, there's y, and there's x. So there's tan of 20 degrees. Sine squared plus cos squared 20. Well, alpha squared, there's 20, sine of 20, cos squared, 1 plus, square root of 1 minus alpha squared. When you square that, you get 1 minus alpha squared, gives you 1. Bit more of big scroll. Tan of 52 equals mu, that's the Greek letter mu. Same sort of thing. Reduce. 180 plus. Tan 52, third quadrant, which is mu. 360 minus 52. Negative tan 52, fourth quadrant, negative mu. Add 360 on. Tan 128. 128, second quadrant, how do we get there? 180 minus 52. And that tan of a second quadrant angle is negative, therefore negative tan 52. Once again, I'm not saying that 180 minus 52 and 52 are the same angle. I'm saying that their x, y, r are the same except for positives and negatives. Negative mu. Cos of 52. So, I've got to do the same thing. Tan of 52 is mu over 1. So let mu, y equal that, x equal that. You see, I say let them equal that because this could be 2 mu and that 2. It's the ratio that we know, but we can let that be the case. By Pythagoras theorem, we know that r is equal to square root of 1 plus mu squared. Notice no plus or minus. Why? Well, because r is always positive. Now we can find cos of 52 and sine of 52. Sine of 52, y over r. Well, we know the y, there's y, and we know the r, there it is. Cos of 52, well, we know the x, we know the r, so we put x over r. And once again, sine squared plus cos squared, well, there we are, the sine squared plus the cos squared, square that, we get mu squared over 1 plus mu squared. There you get 1 over 1 plus mu squared. Common denominator, we end up with 1.